Next question, what are Python's basic data structures and how are they used? So this is a very general sort of question, but it's an important one to understand the answer to and to understand sort of how these things work together. I often say that in my Python courses, people who have programming experience often sort of belittle the need to understand the basic data structures in Python. They say, oh, I want to talk about real objects, real data structures, not these basic ones. And I often say that that's sort of like going to a chemistry class and saying, oh, what is it with you and all these elements? We don't need to understand elements. I want to understand the real chemicals. Well, real chemicals are built out of elements. Everything's built out of elements. And in the same way, every Python program is built out of these basic data structures. So understanding what they are and how they work is very important. So to go through them quickly, we've got sort of like the simplest structures. And then we've got the, let's say, we'll call them sequences, because that's what they're called. And then we'll have more advanced ones. So simple ones are going to be like none. You should know what none is and where it's used, and we'll go over that in a moment. And int, and well, let's call even, let's say, booleans. And then we'll say ints and floats. And that's basically it for the super simple ones. Then we have sequences, which are going to be strings and lists and tuples. The more advanced, and we can even say this is sometimes put in the category of mapping. We're going to say here that this is going to be dictionaries and sets. Okay, so what do we do? How do these work? Well, the simple one, none. None is really used just to indicate that there is no value, right? It is actually a value, but it's to say I'm a placeholder here. I don't actually have a value. And it's used when we return from functions, but we don't actually return a value. It's used for defaults. It's used if you want to sort of initialize a value, but you don't want to give a value there. Booleans, those are really important. Every time you have an if statement, let alone an and or an or something like that, the data has to be a Boolean. If only works with Boolean values, true and false. While loops only work with Boolean values, true and false. And it's important to remember that everything in Python, when put into a Boolean context, when forced to decide, is it true or is it false, we'll say that it's true, other than a few exceptions. And that would be none, false, and anything zero and anything empty. Ints and floats are, of course, going to be our numbers, our numeric types. There's also a complex numeric type, but you don't need to worry about that in most cases. So these simple types, you're going to use them a lot. Certainly you're going to use numbers a lot, but you don't really need to think about them so much. They're not that hard and that complicated. Where things get more interesting is with sequences. And sequence isn't a type in Python, but sort of a family of types. It's a category. And sequence is all, right? So they're all iterable, right? They're all containers of various sorts. They all, they all can use in. They all are subscriptable, which means that we can use square brackets on them. And we can and square brackets, of course, means not only indexes, but also can be used with slices, with index or slice. But let's compare them in different ways. Strings, it might seem obvious that strings contain, well, characters, but in fact, strings in Python don't contain characters, they contain strings. Strings contain strings, so that's an important thing to remember. Strings contain Unicode, but we can say that it contains characters and is immutable, right? You can't change a string. By contrast, lists contain anything, and we'll ignore the fact that for now, traditionally lists contain the same type for all their elements, contain anything, but is mutable. And tuples are sort of a hybrid of the two. They can contain anything, but they're immutable. And that ensures that basically we sort of cover all of our bases. All right, so strings, lists, and tuples, very similar to one another in the fact that they all contain things, but different uses, and the mutability is very important. So what about mappings, dictionaries, and sets? And sets, I don't know if you would really call it a mapping, but we'll put it under that definition for now, for a moment. So dictionaries, they are hash tables. They're used for name-value pairs. All right, name-value pairs. Or key-value pairs, we could even call them, since that's what they're called often. They're used in many, many, many languages, and dictionaries in Python are really important. It's like the most important data structure. They're used everywhere you can associate a name with a value. And so where would you use them? Well, it turns out there are lots of places in programming where you're going to want to associate two things. User ID, username, physical address, credit card number. Well, actually, you shouldn't be storing credit card numbers. But let's say, user ID, last four digits of their credit card number. Or better yet, user ID and total amount that they've bought from you until now. it turns out that there are many, many, many options for dictionaries. And while the keys have to be what's known as hashable, meaning that they can be put into the hash function and given a unique value, and that's true for basically anything that's immutable. I'm fudging a few things there, but that's basically true. The value can be absolutely positively anything. So a dictionary can contain values of integers, strings, lists, dictionaries, modules, objects, functions, you name it. And indeed, at the end of the day, Python doesn't really have variables. Rather, it has a dictionary in which we have the names and the values. So Python actually uses dictionaries. So why do I put sets here? Sets aren't really mappings in that they're not mapping from one thing to another. But a set is basically the keys of a dictionary. So all the properties of a dictionary keys also apply to sets. Why would we care? Because sets enforce the uniqueness and they make it really fast to search in them. That's the other thing. Searching in a sequence is going to be O of n, right? So searching is O of n, which is a fancy way of saying that it's proportional to the length of the item. So the longer the string or list or tuple, the longer it'll take for you to find something in there. Whereas in a mapping or in a dictionary, searching is O of 1. Meaning it doesn't matter how big it is. It'll still take the same amount of time for us to search and to find what we're looking for. Now, it's not 100% true, but it's pretty close to true for our, in general, in our daily lives. You could say it's like O of 1 plus epsilon if you really want. And so sets allow you to search, and they ensure the uniqueness, but they don't have the values, and that's where they're useful. And by the way, dictionaries and sets are both mutable as well, so neither of them can be used as keys in the dictionary. So that's a basic overview of the different basic types in Python. If you have a really good understanding of how these work, where to use them, where they're appropriate, and what their methods are, you're in great shape.